Hello coders, I welcome you all. In this video, we are going to discuss a very important tool for experiment tracking that is widely used in the industry, MLFlow. We have already used one such tool for experiment tracking, DVC, Data Version Control, right? But now let's use the most widely used tool for experiment tracking, which is MLFlow. In this video, we are going to discuss MLFlow. Using MLFlow, we will track not only metrics and parameters, but also we are going to track code, confusion metrics, and model as well. We will discuss more during the practical part of this video that we will start shortly. So let's get started. Now that you know what experiment tracking is, right? You understand that machine learning is all about experimentation. We can conduct many experiments using different algorithms, hyperparameters, and more. But the important question is, why do we conduct experiments? So the answer is to find something better, right? To find something better, we need to compare different experiments. To compare different experiments, we have to keep records of them. If we have records of experiments that we have conducted, then only we can compare different experiments, right? So in experiment tracking, we log or track the experiments. So in the future, we can identify the best experiment and we can use that best experiment in the production. As we discussed, we can also maintain such logs in Excel. But it becomes difficult when the number of parameters and experiments increases. So it's better to use a specialized tool like DVC or MLFlow for experiment tracking so that we can manage everything properly and efficiently. So the question is, what is MLFlow? MLFlow is an open source platform designed to manage the life cycle of machine learning projects. It helps in tracking experiments, packaging code into reproducible runs, and sharing and deploying models. In short, MLFlow simplifies and streamlines the process of developing, tracking, and deploying machine learning models, making it easier to maintain consistency and collaboration across teams. So let's move on the practical part. We will start from the scratch. So let's first open command prompt and let's move to D drive and let's create one directory, exp_mlflow. Let's press enter. Let's go inside this particular directory and let's open VS Code from here using this particular command code dot. Let's press enter. You can see over here. So now let's first open terminal. And first we have to install MLFlow using this particular command pip install MLFlow. Let's press enter. You can see over here, in my case, requirements are already satisfied because I have already installed MLFlow on my system. First, let me show you the GUI of MLFlow without writing a single line of code. So for that, we have to use following command MLFlow space UI. Let's press enter. You can see here MLFlow serving on this particular URL. Let's move cursor over here and let's click on follow link. You can see over here GUI of MLFlow, and currently we are using this particular version of MLFlow 2.15.0. So using this particular command that you can see over here, MLFlow UI, we can run MLFlow on this machine, on this particular machine. At this time, no one else can communicate with it. Only we can access MLFlow. So please remember, currently we are using MLFlow in solo mode. So how we can collaborate with others using MLFlow, that we will discuss in upcoming videos. For now, only we can access the MLFlow in solo mode. Please remember this. So you can see the GUI of MLFlow. You can see two tabs, experiments and models, that you can see over here, experiments and models. So this particular experiments tab is for experiment tracking. And this particular tab, models, is for the model registry. So in this video, we will focus on experiment tracking. Here, in upcoming videos, we will discuss regarding model registry. So you can see two important sections here, experiments and runs, that you can see over here. This one, you can see experiments and runs. So before we move forward, first let's understand the difference between experiment and runs, which is very important concept in MLFlow. To understand the difference between experiment and runs, let's consider our project, water potability prediction using machine learning, which is a classification problem, right? Suppose we first decide to use random forest classifier. After that, we decide to try logistic regression. So you can see here, these are two different experiments. First time, we have decided to use random forest, and then after, we want to try logistic regression. So these are two different experiments that you can see over here, experiments, right? Now let's move on. You know why we are performing these experiments? We are performing these experiments because we want to achieve something good, right? So please remember, in the same experiment, we can perform multiple runs. I'm repeating, in the same experiment, we can perform multiple runs. For example, the first run might use n estimators set to 500, while in the second run uses n estimator to 1000 in random forest classifier, and so on. So this is called a run. One experiment can have many runs. Like we have decided first experiment using random forest. So in random forest, we can try the different values of parameters like n estimators that we have decided to use 500 in the first run and 1000 in the second run. So this way, one experiment can have multiple runs. So now you can relate. For one project, we can have multiple experiments. In multiple experiments, we can have multiple runs, right? Suppose after that, we move to our second experiment where we have decided to use logistic regression. So in this case, we might try different penalties. Penalties means the type of regularization to use, such as L1 and L2. So in this particular second experiment, we perform multiple runs with these different penalties. So as we discussed, one experiment can have multiple runs, right? Hope you understand the difference between experiment and runs. I am repeating, in one project, we can have multiple experiments. Multiple experiments can have multiple runs. If you can't understand this, shortly we will perform practical on this. Now you can see tabs on the MLFlow, experiments and runs. You can also see default over here. You can observe, although we have not created any experiments yet, MLFlow has created this particular default experiment by default. If we do not explicitly create an experiment, our experiments will be stored in this particular experiment, default experiment. Hope all of you are clear with this. I am repeating, if we do not explicitly create an experiment, our experiments will be stored in this particular experiment, default experiment. Again, I will show you this practically shortly. Here you can see the runs. It will show you information regarding each run of this particular experiment. Currently default experiment. Just we have discussed the difference between experiment and runs. Hope all of you are clear with this. One experiment can have multiple runs. Now let's move to VS Code. Can you see here? A new folder has been created with name ML runs. When we have executed this particular command, MLFlow UI. This ML runs folder contains metadata about our experiments. Currently, this folder holds metadata for our default experiment that you can see over here. Metadata about our default experiment that you can see over here. Experiment name, default. And you can see here experiment ID 0. Please remember, MLFlow assigns unique ID to each and every experiments. ID 0 assigned to the default experiment that you can see over here. Our default experiment with ID 0 and name default. When we create different experiment and runs, you will find all of them in this particular folder, ML runs. So please remember, MLFlow GUI is displaying all the information from here, from this particular folder, ML runs. So MLFlow GUI, this particular GUI is fetching information from this particular folder, ML runs, and displaying the information here on the GUI, right? Now let's move to the practical part. You can see that at the beginning of the project, we wrote the code inside a Jupyter notebook that you can see over here. Here we import various libraries that we require. This line loads the dataset into a pandas data frame. And as you can see here, we are checking for the missing values. You can see that missing values are present in pH, sulfate, and trihalomethanes columns that you can see over here. So now here we are splitting our dataset into two parts, one for training and one for testing that you can see over here. We will use the training set to train our machine learning model, and we will use test set to evaluate the performance of our machine learning model. So here we can say our test set contains unseen samples, right? And as you can see here, we are filling the missing values using the median of the respective columns, both for the training set and the test set that you can see over here. And here we have imported our classifier, random forest classifier, as well as this particular library, pickle. And here we are separating the independent and dependent variables of the training set for model training. And as you can see here, we are training our random forest classifier on the training set with n estimators set to 50 that you can see over here. And here we are saving our model using pickle that you can see over here. Now let's move on. As you can see here, we have separated the independent and dependent variables of the test set. And here we are importing various modules to calculate accuracy, precision, recall, and F1 score in order to assess the model's performance on the test data. And as you can see here, we are loading our saved model that we have saved over here. And here we are performing predictions on test data, means on unseen samples, and storing the predicted results in Y-pred. And here we are calculating accuracy, precision, recall, and F1 score using the actual values and predicted values from our model. This one, actual values and predicted values by our model. And here we are printing the results for accuracy, precision, recall, and F1 score that you can see over here. Now let's create two new folders, one with name data and second with name SRC. Now let's paste our dataset into the data folder. You can see our data set. Let me close this and let's click on SRC and let's create new Python file into this particular folder, SRC folder, with name water_model.py. You can give any other name as well. Now first we have to copy and paste this code from Jupyter Notebook to VS Code. Let me copy this. Let me paste it over here. So let me copy the code from Jupyter Notebook to VS Code. Let me paste it over here. Again, back to Jupyter Notebook. Let me copy this. Let me paste it over here. Again, let me copy this code and let me paste it over here. Let me save this file. So here, let me copy this path for our data set. So we have to replace this with this particular path and let's change this to double quotes. Now done. Now let's first import MLFlow. And here we are going to track this particular parameter of random forest classifier, n estimators. And you can see current value of n estimators, 500. And also we are going to track metrics like accuracy, precision, recall, and F1 score. For that, here how to write with MLFlow dot start underscore run. And let's put all this statement inside this. Let's save our file. You can see over here. As I said, we are going to track and log metrics like accuracy, precision, recall, and F1 score. So for that, let me copy these print statements. Let's create space over here and let's paste it over here. So in place of this, we have to write MLFlow dot log underscore metric. Again here, MLFlow dot log underscore metric. Same over here for recall as well. MLFlow dot log underscore metric. Same for F1 score as well. MLFlow dot log underscore metric. Let's save our file. Also, we are going to track this particular parameter of random forest classifier. So here we have to write MLFlow dot log underscore param and underscore estimators, comma, and underscore estimators. Let's save this file. You can see that the syntax is very similar to DVC that you can see over here, right? So now we are going to run this particular experiment, and here you can observe one thing. We haven't provided any name to this particular experiment. Therefore, it will be stored inside the default experiment, right? So let's create new cell and let's run this particular experiment. src/water underscore model dot py, our file name. Let's press enter. You can see our experiment runs successfully. You can see here. Output of this print functions accuracy, precision, recall, and F1 score. Now let's move to our MLFlow GUI. You can see here. 1 means here we have to press this refresh button. You can see our experiment, default experiment, and our first run of this particular experiment default that you can see over here. Let's click over here on run name. You can see here description about our run. Created at date and time. Created by user name. You can see experiment ID is 0 for default experiment. Status is finished because we have successfully executed this particular experiment. You can see run ID for this particular experiment, default experiment. So experiment ID is 0 and this is run ID for our first run. And you can see duration, time required to run this particular experiment that you can see over here. Tag that we will discuss shortly. You can see source file name water underscore model dot py that we have created over here. Water underscore model dot py. And you can see here we have tracked this particular parameter of random forest classifier and estimators with value 500 that you can see over here as well. And estimators is set to 500. And you can see here metrics, 4 metrics that we have tracked: accuracy, F1 score, precision, and recall that you can see over here in our code. Metrics, accuracy, precision, recall, and F1 score, and 1 parameter of random forest classifier and estimators that you can see over here. Hope all of you are clear with this. So here it is showing only 1 parameter of random forest classifier and estimators because that's the only parameter we have logged. If you are using multiple parameters of random forest classifier, all of them will be shown here. So now we have just run one experiment with only 1 run. Since we didn't specify any experiment name, it was stored inside the default experiment that you can see over here. Now let's execute our second run. Let's move to VS Code And let's change the value of n estimators and let's set it to 1000 in place of 500. Let's save this code. Let's clear this output and let's execute this particular code one more time. You can see our experiment runs successfully. Let's move to our GUI. You can see here. Let's press this refresh button. You can see here our second run. Let's click on this. You can see description about this particular run, our second run. And now we are tracking n estimators with value 1000. You can see matrix value for our second run with n estimators 1000, accuracy, F1 score, precision and recall that you can see over here. For this particular experiment, we have performed 2 runs. So as I said, one experiment can have multiple runs that you can see over here. Hope all of you are clear with this. Now let's move to VS Code. So now let's check this particular folder, ML runs. You can see we have executed 2 runs that you can see over here. So as I said, the MLFlow GUI fetches information from this particular folder, ML runs, and displaying information over here that you can see over here. So you can see that currently we have only one experiment named default experiment, right? And we have multiple runs that you can see over here. As we discussed, one experiment can have multiple runs. Now we can select multiple runs like this. And also we can compare them. To compare these 2 runs, we have to click this particular button, compare. You can see over here, n estimators 1000 and 500 in parallel coordinates plot that you can see over here. Also we have scatter plot that you can see over here. Also box plot that you can see over here. And contour plot as well that you can see over here. And here you can see comparing 2 runs from one experiment that you can see over here. So now let's move on. Let's click over here, default. As you can see, we are currently using the default experiment. Now let's create our own experiment. So now let's move to VS Code and let's click over here. So for this new experiment, we are going to use gradient boosting classifier instead of random forest classifier that we have used over here. So let's click on this particular folder src and let's create new Python file, water underscore model underscore gb.py. You can give any other name as well. Let's select our previous code. Let's copy this particular code. Let's move to our newly created Python file and let's paste it over here. So now here first we have to import gradient boosting classifier, and here we are going to track n estimators of gradient boosting classifier. So here also gradient boosting classifier. Let's save our file. I think all done. And you can see current value of n estimators 1000. So now let's create new experiment. We can create a new experiment using code, but for simplicity we are going to create it using the GUI. So let's move to our GUI and here you can see new experiment. So let's click over here and here you can give any name, water underscore exp2, and currently we do not have any artifact location. So let's keep as it is and let's press this particular button, create. You can see our new experiment has been created with this particular name. Let's click over here. Let's copy this. Let's move to VS Code and let's give our experiment name over here at the top. So please remember, we can set the experiment name in several ways. One method is to use MLFlow.set_experiment, and here we have to give our experiment name that just we have created using GUI, this one. And another method is to specify the experiment ID over here inside start underscore run. Experiment ID is equal to this particular ID, but we are going to create experiment using this method set underscore experiment. Let's save our file. So please remember, one of the advantages of using MLFlow dot set underscore experiment means this particular method is that if the experiment does not already exist over here, it will create a new experiment with the given name if we are using this particular method. So now let's execute our second experiment and the first run of our second experiment. Let's clear this and we have to use following command /water underscore model underscore gb dot py. Let's press enter. You can see our experiment runs successfully. You can see over here accuracy, precision, recall and F1 score are printed over here because of these statements. Let's move to MLFlow GUI and you can see over here. Let's press refresh button. You can see over here. Let's click over here. You can see created at, created by and experiment ID that you can see over here. Status finished. Run ID for this particular experiment. Duration, text, source file and you can see over here and underscore estimators. We have set it to 1000 and you can see over here metrics, accuracy, F1 score, precision and recall that you can see over here. Now let's change and estimators to 500. Let's save this file. Let's clear this and let's execute our code one more time. So this will become our second run of our created experiment. This particular experiment. Now done. Let's move to our GUI. Let's click over here and you can see over here our second run with n estimators is set to 500. And you can see over here accuracy, F1 score, precision and recall with n estimators 500 that you can see over here. So you can see our created experiment contains 2 runs that you can see over here. So as we discussed, one experiment can have multiple runs that you can see over here. Now let's move on. You can see here we have only tracked metrics and parameters. But now let's try to log plots, also called as artifacts. So what do you mean by artifacts? Artifacts are any files generated during a machine learning experiment that you want to save and track. This includes trained models like .pkl files, datasets, code, and visualizations like plots. These artifacts are logged with your experiment runs, enabling you to version, compare, and retrieve them later, ensuring your experiments are reproducible and well documented. So let's first log and track the confusion metrics. Let's move to VS Code. And first we have to import from sklearn.metrics. Let's import confusion metrics. And also we have to import matplotlib.pyplot as plt. Also we have to import seaborn as sns. Let's save our file. Now let's move down and let's create a confusion metric plot. So confusion underscore metric, that just we have imported actual values and predicted values by our model. Let's assign it to one variable cm is equal to this statement. Let's set figure size using plt.figure and fig size 5 cross 5. And let's save our confusion metrics into heat map of seaborn and let's set anode to true. Let's provide x label predicted and y label actual and predicted values. Let's give title to our confusion metrics. Now we have to save our confusion metric. Now we have to save our confusion metrics as an artifact, means as an image. So for that we have to use plt.savefig. You can give any name. Let's give confusion underscore matrix dot png. Now let's log our created confusion matrix using MLFlow. So again, we have to use MLFlow dot this time log underscore artifact. And here we have to provide this particular image that just we have saved. Let's save our file. Now all done that you can see over here. So currently we are going to log confusion matrix using MLFlow that you can see over here. Now let's clear this and let's execute our experiment, means this particular Python file. Let's press enter. You can see over here this particular error, mlflow.exceptions.mlflow exception. The configured tracking URI scheme file is invalid for use with the proxy MLFlow artifact scheme. The allowed tracking schemes are HTTP, HTTPS. So you can see this particular error. As you know, currently we are running MLFlow in solo mode. No one else can communicate with it, right? So this error indicates that if you are not running a tracking server, means tracking server allows all team members to communicate with each other. You can log metrics and parameters, but you can't log artifacts when working in solo mode. That we are currently working in solo mode. So MLFlow is telling if you are working in solo mode, you can't log artifacts. So what is the solution? We have to add one line over here because currently the URI is set to file by default that you can see over here. So we have to change it. We need to write one line over here using HTTP or HTTPS. Let me show this. So let's move to top and let's add this particular line. MLFlow set underscore tracking underscore URI. And here let's set HTTP 127.0.0.1 and port number 5000. Let's save our file and let's execute this particular file. Now our experiment runs successfully that you can see over here, and you can see the new folder has been created with this particular name, ML artifacts. You can see over here it contains this particular image. Let's click over here that you can see over here our confusion matrix. Let's close this file. Now let's move to our GUI. Let's refresh this. You can see over here this is our current experiment and our failed experiment because of error, right? Let's click over here. You can see over here description, model matrix with chart, and let's move to this particular tab, artifacts. You can see over here confusion matrix that you can see over here. So this way we can log confusion matrix using MLFlow that you can see over here. Hope all of you are clear with this. Now let's move on. So you can see our code. So we have logged different metrics: accuracy, precision, recall, and F1 score. Also this particular parameter and underscore estimators. Also confusion matrix, right? So now let's log the model. So for that, first we have to import MLFlow.sklearn. Let's save this file. Let's move down, and after this let's add MLFlow.sklearn.log underscore model. Here we have to give model instance, this one, and here model name, so we can identify our model easily. Let's copy this model name, gradient boosting classifier, and let's paste it over here. Let's save our file. Let's clear this and let's execute our file. You can see our experiment runs successfully. Let's move to our GUI. Let's click over here. This is our current run that you can see over here. Description, N estimators and metrics, accuracy, F1 score, precision, and recall. You can see model matrix. Let's click on artifacts. You can see over here information regarding our model that you can see over here. Pickled model, model.pkl. You can see over here information about our model. This is our saved model, model.pkl. And also this file has been created, requirements.txt, and you can see our confusion matrix that just we have logged, that you can see over here. So this way we can not only track and log metrics and parameters, but you can see we can also track and log artifacts like confusion matrix and model as well, that you can see over here, our model. Now let's move on, and now we are going to track our code. So here MLFlow dot log underscore artifact, and to log and track our code we have to use this underscore underscore file underscore underscore. Let's save this and let's execute our code. So here we are going to log and track our code, this code that you can see over here. Now you can see our experiment runs successfully. Let's move to our GUI. Let's click over here, and this is our current run. You can see here description, model matrix, and let's click on artifacts. You can see over here potter underscore model underscore gb.py. You can see over here. So this way we can log our code as well using MLFlow, that you can see over here. So this way we can track and log metrics, parameters, confusion matrix, code file, and model as well, that you can see over here. Hope all of you are clear with this. Now let's add tag. Let's click over here, and you can see here tags. So we are going to add tags. So why need to add tags? Tags will help in searching. Let me show you this practically. Let's move to our code. Let's move down, and here MLFlow dot set underscore tag, and let's write author name data thinkers, and also let's add another tag model and GB gradient boosting classifier. Let's save our file and let's execute our file. You can see our experiment runs successfully, and we can add tags like this. Let's move to our GUI. Let's click over here, and this is our current run. Let's click on this. You can see here tags author, data thinkers, model, GB. Now let's back to our experiment, and here we can search like this. Tags dot author is equal to, you can give particular name, data thinkers. You can see over here this particular experiment. Let's move back, and in place of author, let's give model equal to GB. Let's press enter. You can see over here. So this is the advantage of using tag. If you have multiple runs, you can search particular run like this, that you can see over here. So this way we can add tags to our runs, that you can see over here. This will make easy to search particular run. Using tags, we can search particular run as per our requirements. Hope all of you are clear with this. So now let's move on. How we can delete particular experiment and particular run. So by clicking on this particular button, you can delete particular experiment, and by clicking on this particular run and by pressing this delete button, you can delete particular run. You can see one experiment run will be deleted. Just press this button delete. You can see over here. This way we can delete particular experiment and particular run of that particular experiment. Hope all of you are clear with this. So this way we can perform experiment tracking with MLFlow. Hope all of you are clear with this. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye bye. See you in the next video.